Of all the modern-day advances, the control of electricity is certainly one of the most revolutionary.
Electricity is everything to the modern world. Try and think of something that doesn't use electricity. It's everywhere. We cannot see electricity, but we certainly know the impact it has.
And with the invention of a single machine, electricity completely energized the modern execution. They call this device the electric chair.
Since it was a modern-day machine, really it was sort of designed with the best of intentions. They designed it thinking it would be more humane, a less cruel way of punishment, a less inhumane way of carrying out execution. Whether or not that's actually the case is kind of up for debate.
In the electric chair, a condemned prisoner becomes part of a closed circuit. Electricity leaves the power supply as electrons move through the wire. The electricity then enters the headpiece, travels through a conductive sponge soaked with saline, and enters the skull. The electrical current then courses through the human body, exiting from an electrode on the leg, where a second conductive sponge sends it right back to the power supply. The typical electrocution cycle starts with a high voltage jolt and ends with a lower one.
When they're brought into the execution room, obviously you see the chair sitting there. It really only has one purpose. You know you're not going anywhere anytime soon. You have to be sat down in the chair, be strapped to it. You've got the electrodes being attached to both your head, your legs being shaved so the electrode can be placed onto there. It's a very real experience, and no matter how much you've been putting it off until then, all of a sudden it's going to come home.
Contrary to popular belief, the electric chair is not electric. No current travels through any part of the structure. So just about any sturdy non-conductive chair can serve as a front row seat to an electrocution.
So the human body is really just there to bridge the gap between the two electrodes, just letting the electricity conduct all the way through.
But just how much voltage does it take to electrocute the condemned?
Electric chairs maybe vary from 1600 volts to perhaps a high of 2600 volts in recent years. And here we have an array of 8100 watt light bulbs. We could visualize the amount of energy, say, of one of the lower energy chairs, and it would look something like this.
All of these light bulbs are the equivalent of 1600 volts. A typical household outlet delivers just 120 volts. So the electric chair has 13 times more voltage than household current.
In order to drive this much energy into a person, it takes a lot of voltage. So to do that, they either need a transformer to step the voltage up or a generator, but something that delivers much more power than a home outlet.
The power is supplied from a control system in an adjacent room. This is where the high voltage current of electricity is unleashed through the condemned. The entire electric cycle lasts from 15 to 30 seconds, but it's not the voltage that kills you.
Think of it as though voltage is a pump, capable of pumping electricity. And think of electricity like water flowing in a pipe, the wire being pipes. The bigger the pump, the more water it will push through the pipe.
During an electrocution, it's actually the amperage, or rate at which electricity flows into the victim, that's lethal. Just 1 amp can kill a human, but how it kills is up for debate.
Some people have inferred from the idea that the skull insulates the brain that not enough electricity will get to the brain to shut it down during an electrocution.
There's a simple visual test to observe if voltage can travel through the skull directly into the brain. It requires a purchase from the local butcher shop to simulate the human brain.
Here we have brain matter, and we have bone to simulate skull. We're going to use an oscilloscope to see if current does get to the brain, even when you apply voltage to the skull.
An oscilloscope is a device that translates voltage into a graphic display. When there is no voltage, the screen is black or shows a flat line.
So there's no electric current running through the brain tissue right now. I'm going to introduce some with a stun gun. This is about 2,000 volts. You're going to be able to see the current in between the two electrodes until I pass it into the brain. That current will disperse throughout the brain tissue. You'll see it register here on the oscilloscope until I pull the electrodes back out.
So now there's a baseline. The oscilloscope shows high voltage traveling through the brain matter. Coming up, does the skull actually protect the brain from electricity during an electrocution? As humankind begins to understand electricity in the modern age, executioners capitalize on its lethal attributes. The inventors of the electric chair know that electricity can kill, but they don't know how. One theory is that the skull insulates the brain from the electric jolt. As a result, the electricity kills the brain by cooking it. An initial baseline test shows that high voltage travels easily through brain matter. But the brain is protected by the skull, and it's the skull where the voltage first hits the victim.
Some people think because the skull insulates the brain that not enough electricity will get to the brain to shut it down during an electrocution. So we're going to use a piece of bone to simulate skull. And we're going to zap the skull and see if we still get the same readout from the brain tissue. Yeah, you can see still quite a bit of electricity going through the brain tissue, even when it has to pass through the skull.
The high voltage easily travels from the skull into the brain. But how does this current kill? Does it cook the brain, or does it short it out?
There's a myth that exists that when a person is electrocuted in a legal electrocution, that their body is going to heat up to a boiling temperature and that their eyeballs are going to explode and all these terrible things are going to happen. So I'm going to take a hot dog, and I have to warn you that what I'm doing is dangerous. I would actually characterize it as stupid. Do not try this at home. I'm going to put one end of a nail into one end of the hot dog. I'm going to put the other end of the nail into the other end of the hot dog, push it in a little bit to make some good contact. Okay, here we go. There we go. And you'll notice that there's not a lot happening. This would be very much like a legal electrocution in the sense that the body itself isn't going to heat up massively. Okay, at this point we're starting to hear the effects of heating in the hot dog.
It takes nearly 1 minute for signs of heat to appear on the hot dog. This is more than double the time of the electric cycle during an execution.
So I'm going to unplug this. I'm going to see if we can get a temperature on the hot dog. The reading would be just a little over 106 degrees. Now that would be consistent with what we know about legal electrocution. And if I pick this up, it is warm to the touch, but it's not exceptionally hot.
A rapid rise in body temperature is not enough to quickly kill a healthy adult. So just how does a person die when sentenced to the electric chair?
Basically, every electrical cell in your body is going to what we call depolarize, and that basically means fire and do its job.
Say you have one neuron in your brain that's responsible for you breathing in. You have another neuron in your brain that's responsible for you breathing out. You stimulate both of those at the same time, your body can't breathe in and out, and same thing for your heart beating, same thing for any system in your body. When you're firing all of those neurons at once, you're completely overloading your system.
So the electric chair kills by completely overwhelming and confusing the human body. The brain effectively shorts out, and eventually the heart stops beating. During a legal electrocution, the jolt delivers 2 cycles of electricity. The high voltage of the first cycle takes out the brain and nervous system.
This is going to be the nerves going to his brain, nerves going to his heart, the nerves going to his arm, to his bowels, to his mouth.
It usually results in permanent brain death, but it might not be enough to stop the heart, which can continue beating.
Their muscles will still contract, their face will contort.
The on-site medical examiner can only pronounce death upon cessation of the heart. This is why the second cycle has lower voltage and lower amperage. This causes the heart to fibrillate, throwing the muscles out of rhythm, and induces a heart attack.
Some people may die immediately due to cardiac arrest, and others may suffer a little longer until eventually their heart or their brain does give out.
Probably as our society has evolved, it certainly does not have the appeal that perhaps it had 100 years ago. The difference, I think, is that maybe the definition of what is cruel and unusual has changed.
Today, most states have abandoned the electric chair as they search for more humane methods of capital punishment. But electricity has pushed society forward in countless ways. The technology of the modern era definitely advanced the engineering of execution equipment. In an attempt to create more humane death devices, machine builders mechanized old techniques borrowed from the military and exploited